Okay, I think we can start. So good morning, afternoon, evening, everyone from wherever you are located. Welcome to iTrust webinar on a study of existing guidelines and mitigating measures for cyber risks in shipboard OT systems. My name is Mark Goh and I'll be your MC this morning for this webinar. And this is the second of 3 webinars that iTrust is organizing around this topic. And for those who are unfamiliar with iTrust, we are a Center for Research in Cybersecurity at the Singapore University of Technology and Design, SUTD. And one of our main focus is on the research into the safety and security of critical infrastructure such as power and water systems, as well as shipboard systems. And before we begin, iTrust wishes to thank the Maritime and Port Authority of Singapore, MPA, and the Singapore Maritime Institute, SMI, for their support in this webinar, and also their help in publicizing it. And we also like to thank SMI for funding iTrust to carry out this 1-year research study. Next slide, please. So here's the program for this morning's webinar. Professor Aditya Mata, Center Director of iTrust, will kick off the webinar with his welcome remarks. And then Professor Zhou Ying, the study's principal investigator, will provide an overview of this study. And in our first webinar, we shared a list of shipboard OT systems that are under consideration, as well as their corresponding cyber risks. And today, Priyanka and Ruchita, our senior research assistants, they will present the corresponding mitigation measures for these cyber risks that they have identified. And then we will have about 30 minutes of Q&A and followed by closing remarks. So without further ado, it is my pleasure to welcome Professor Aditya Mata to give his opening remarks. Aditya, please. Thank you.
Thank you very much, Mark. Greetings to all attendees of the second webinar that focuses on cybersecurity of shipping OT systems. As some of you may know, in July 2013, Professor Todd Humphrey from UT Austin and his research group, they demonstrated how a yacht can be moved to a location that they desire or location that is an attacker desires by a simple spoofing attack. Later in 2018, Naval Dome, a company in Israel, conducted a study to find out whether actual ships in operation can be hacked, and they showed very effectively that ships, almost all systems of a operational ship can be hacked into and taken control over. While these 2 reports are essentially demonstrations, not done by hackers, but by researchers, they do point to the challenges that are before us in creating safe and secure shipping OT systems. Around the time when UT Austin researchers under Todd Humphrey demonstrated the attack on a yacht, just before that, iTrust was set up in 2013. And iTrust's focus, as Mark just now mentioned, has been on the design of secure critical infrastructure. We have focused so far on water, power, and IoT as it relates to critical infrastructure. Now, under Professor Jianning's leadership, we are also moving into a 4th area of importance in the domain of critical infrastructure, which is shipping systems. iTrust is focused on several issues that arise in securing critical infrastructure. Of course, it starts with anomaly detection, but then it also goes into incident response, design of individual processes, design of individual subsystems as small as pumps or valves, etc. How the security posture of a system design affects the design of these devices that together form a large system. So with that, I would like to conclude and say that this is going to be a very useful webinar. And I am thankful to Professor Jianning and his research group and all the supporters of this research that Professor Jianing has undertaken in the area of shipping OT systems, securing shipping OT systems. I wish you all the best for this webinar, and I hope this will give Professor Jianing and his group a lot of guidance in how to proceed further to meet this challenge. Thank you very much.
Thanks, Aditya. So we'll now hand over the time to Jianing to give his introduction for this study. Jianing, please. Thank you.
Okay, thank you, Professor Aditya, and thanks, Mark. Hello, everyone. Welcome to our second webinar on maritime cybersecurity. And as the PI of this project, thanks also to the support from MPA and SMI on this research. So let me recall the motivation of our work. Maritime industry is one of the key engines of Singapore's economy. It has showed an increasing trend of adoption of more ICT technologies in maritime industry with the enhanced monitoring, communication, and connected capabilities. This will significantly improve the productivity and reduce the operational costs. But on the other hand, the increased connectivity also will introduce more cyber risks. The shipboard OT systems will be subject to those cyber attacks and disrupt safe operations of a vessel or will cause catastrophic consequences. So we need to establish a guideline for cyber risk management on shipboard OT systems so that the ship owners can use it to recommend the best practice for adoption, and also maritime authorities can use it to perform the vessel inspection. So far, there are quite a number of regulations and industry guidelines on maritime cyber risk mitigation strategies being proposed by the various societies. For example, the IMO released the guidelines on maritime cyber risk management in 2017. BIMCO also released guidelines on cyber security onboard ships in 2020. ENISA provided a good practice of cyber security in maritime sector in 2019. And the DMV also provided the cyber security resilience management of ships and mobile offshore units in 2016. ABS released the guidance note on the application of cyber security principles to marine and offshore operations. So those are the existing guidelines we have seen being released. However, Singapore lacks its own guideline that can be easily referred to and being adopted by maritime authorities and ship owners. So, we initiated this project from September 2020. We aim for the cyber risk management study in shipboard OT systems, including the navigation, communication, propulsion, and power control, as well as cargo management systems. So in our first webinar, we shared our investigation of the cyber risks in those major shipboard OT systems in December last year. In today's webinar, we will further study the existing guidelines for cyber risk management and also propose our mitigation measures against those cyber risks. We will also prepare a third webinar in August to provide a new guideline for Singapore's context. And this new guideline, a couple of factors will be considered. We should balance the risk and the costs for enforcement of this guideline, and we will take a tiered security approach for major shipboard systems, and we will also make it easy for adoption by ship owners and enforcement by maritime authority. Here are the shipboard OT systems to be investigated. There are mainly 4 shipboard OT systems. The first is the communication systems, and the second is about the propulsion and the power control systems. The third is navigation systems, and the last one is the cargo management systems. Those are the 4 major shipboard OT systems being covered within our investigation. So now I will hand over to Priyanka. She will share our study of our existing guidelines for cyber risk management.
Thank you, Prof. A very good morning, everyone. I'm Priyanka, and today I will be presenting on the study of existing guidelines for maritime cyber risk management. As we all know, the maritime industry is an important constituent of the worldwide economy as it plays a major role in transporting cargo, goods and materials to and from different ports. And vessel infrastructure is becoming complicated due to the increased usage of digital technologies for their operations, such as navigation, cargo management, communication, power control, propulsion, and other machineries. So lack of good cybersecurity practices could lead to compromise of OT and IT systems and cause serious damage to the crew, vessel, and the cargo. So the aim of our research is to study the cyber risk management guidelines published by various maritime organizations, classification societies, and other institutions, and we will discuss their significances. So the list of organizations whose guidelines we have studied include the International Maritime Organization, Baltic and International Maritime Council, the European Network and Information Security Agency, Det Norske Veritas, American Bureau of Shipping, and the Institution of Engineering and Technology. So for each of the reports published by these organizations, we will discuss what the guidelines focus on, who the target audiences are, and also some of their policies. First, we will look at IMO's guidelines. The International Maritime Organization is a United Nations agency whose mission is to promote safe, secure, and sustainable shipping through effective review, development, implementation, and compliance with IMO's instruments. IMO released the guidelines on maritime cyber risk management in 2017, and the guidelines in this publication is intended for all maritime organizations and aimed at encouraging safety and security management practices in the maritime cybersecurity industry. It is true that Risk management is fundamental to safe and secure shipping operations, and it has traditionally been focused on operations in the physical domain, but greater reliance on digitization, integration, automation, and network-based systems has created an increased need for cyber risk management in the shipping industry. So the guidelines published by IMO provide high-level recommendations for maritime cyber risk management. Few elements of cyber risk management were defined by IMO. The first one is that cyber risk management should start at the senior level, and cyber risk awareness must be established at all the levels of an organization. This must be done to ensure a holistic and flexible cyber risk governance scheme, which is in continuous operation and constantly evaluated through effective feedback mechanisms. The next element is to assess and compare an organization's current and desired cyber risk management postures to design an effective cyber risk management approach. So stakeholders must take necessary steps to safeguard shipping from current and emerging threats and vulnerabilities related to digitization, integration, and automation of processes and systems in shipping. The 5 functional elements of cyber risk management defined by IMO includes identify, protect, detect, respond, and recover. Processes like defining roles and responsibilities, identifying assets under risk, implementing detection and protection measures, identifying backup and restore measures are some of the guidelines that basically present the functional elements that support an effective cyber risk management approach. So these functional elements are not sequential, all should be concurrent and continuous in practice and should be incorporated appropriately in a risk management framework. Next, we will look at the guidelines by WIMCO. In 2020, the Baltic and International Maritime Council and other maritime associations such as Chamber of Shipping of America, Digital Container Ship Association, Intercargo, Intermanager, Intertanko, ICS, IUMI, CIBAS, and World Shipping Council released the guidelines on cybersecurity on board ships. So the main objective of their guidelines is to improve the safety and security of seafarers, the cargo, ships, which is basically the entire maritime ecosystem. They actually intend to guide organizations in the development of a proper cyber risk management strategy in line with relevant regulations and best practices on board a ship, with a focus on several other aspects such as work processes, equipment, training, incident response, and recovery management. So we are all aware that shipping is relying increasingly on digital solutions for the completion of everyday tasks. But the rapid developments within information technology present ship owners and other players in the maritime industry with increased possibilities for operational optimization, cost savings, safety improvements, and a more sustainable business. However, these developments rely on increased connectivity, often via internet between servers, IT systems, and OT systems, which increases the potential cyber vulnerabilities and risks. So this report addresses the major cyber risks in shipboard OT systems and provides guidelines on how to protect against cyber threats and also incident response and recovery measures. So this picture defines the cyber risk management approach suggested by WIMCO, which is to identify threats, identify vulnerabilities, assess risk exposure, develop protection and detection measures, establish response plans, and respond to and recover from cyber incidents. So they basically define that cyber risk management must identify roles and responsibilities of users, identify the system's assets and data under risk, must implement technical and procedural measures to protect against a cyber incident and timely detection of cyber attacks, and finally, contingency plans must be established. So some of the guidelines given in the report includes implementing access lists to network systems to ensure that only appropriate traffic will be allowed via a controlled network or a subnet. Closing unused ports to prevent unauthorized access. And controlling networks that provide suppliers with remote access. And implementing secure locks for the areas containing sensitive OT or IT control components. And ensuring that the exchange of sensitive information is protected, for example, encryption. So the next one is by ENISA, the European Network and Information Security Agency. ENISA is a European Union agency for cybersecurity that works to develop advice and recommendations on good practices in information security. They had published 2 documents on maritime cybersecurity practices, and their study was made through desktop research, individual interviews, questionnaires, and workshops. So ENISA published their first report on the analysis of cybersecurity aspects in the maritime sector in 2011. The target audience of this study consists of organizations, national authorities, government bodies, and private companies that are involved in the maritime sector and especially in its cybersecurity aspects. So this study brings forward recommendations that organizations involved in the maritime sector should consider to ensure network resilience from the view of information system protection. So from the study, they have come up with a list of findings and challenges such as low awareness and focus on maritime cybersecurity, complexity of maritime ICT environment, fragmented maritime governance context, inadequate consideration of cybersecurity, no holistic approach to maritime cyber risks, overall lack of direct economic incentives, and inspiring initiatives. So for all the issues that is highlighted above, a set of impacts and recommendations were given. So as I said before, the second document published by ENISA is on the good practices for cybersecurity in the maritime sector, published in 2019. So this report focused on port cybersecurity, aiming those in charge of IT and OT security within the port ecosystem and other personnel in charge of applying cybersecurity practices. It is also applicable for the secondary stakeholders in the port ecosystem, such as port ecosystem associations and especially members in charge of IT and OT security matters. And their main objective were to provide a baseline of good practices to ensure cybersecurity of port systems and services. So some of the key findings of the report is that for a number of years, ports have been undergoing a digital transformation in order to meet emerging challenges, optimizing existing processes, and introducing new capabilities such as automation and real-time monitoring of operations. So this digitalization has been centered on the interconnectivity of information technology and operational technology assets and the introduction of new technologies such as cloud computing, big data, and Internet of Things. Also, ports are responsible for certain support services and data exchange between port and different stakeholders, such as mandatory declarations, operational data, which is related to port services, financial data, and navigation data. So the report also identified the challenges faced by the ports in cybersecurity, both in the information technology and the operational technology worlds, in relation to critical operations, stakeholders, ecosystem, and assets identification. So the study outlines good practices for cybersecurity in the maritime port ecosystem, both concerning IT systems and OT systems. So the security measures were categorized in a logical manner into 3 main groups: such as policies, organizational practices, and technical practices. So under each of these categories, subcategories were defined and a set of recommendations were given. So for example, under network security, some of the technical measures recommended are to define a network segmentation architecture, perform regular network scans to detect malicious networks, and to define perimetric security with filtering rules. The next guideline we'll be looking at is by DNV. DNV is a maritime company that provides classification, verification, risk management, training, and technical advisory to the maritime industry. In September 2016, DNV addressed the issues and challenges faced by the maritime industry with the publication of Cybersecurity Resilience Management for ships and mobile offshore units in operation. The recommended practices on cybersecurity given in this document is built on recognized guidelines issued by IMO and WIMCO that we just saw. So since cybersecurity is becoming critical not only for data protection, but also for safe and reliable operations, concerns about critical infrastructure, public safety, risk reduction, and securing business continuity is also increasing. So the guidelines are intended to those who are working towards enhanced cybersecurity of their assets in operation, such as owners, managers, operators of ships and mobile offshore units. Recommendations have been given on the following topics, such as cybersecurity assessment, cybersecurity improvements, verification, and validation. So some of the technical improvement measures were given on network segregation, usage of default accounts and passwords, hardening secure remote connections, software configuration management, and software patch management. The next guideline we'll be looking at is by ABS, American Bureau of Shipping. ABS is an American maritime classification society established to promote the security of life, property, and the environment, primarily through the development and verification of standards for the design, construction, and operational maintenance of marine and offshore assets. So ABS published a document, Guidance Notes on the Application of Cybersecurity Principles to Marine and Offshore Operations, to provide advice on cybersecurity practices for shipboard systems. So this guidance notes on the application of cybersecurity principles to marine operations are organized as best practices and recommendations for each of the three sets of capabilities. So what's the capability? A capability is basically defined as the ability to execute a specified course of action. And it is broad in that it includes people, systems, data, and processes. So the three levels of capabilities are defined, which is the basic capability set, developed capability set, and the integrated capability set. Also, the categories of capabilities within the ABS model include practices, programs and processes, protected resources and access, and risk understanding and management. So this figure illustrates the basic capabilities that is required to build a cyber-safe program to support cyber-secure systems. So the main part of the program is the information technology fundamentals, which is commonly employed to support a business or an operational system. We can see that the 9 capabilities are arranged generally, which help organizations of all sizes to understand the functions and factors and implement them according to their expenditures. The next one is the developed capability set, which shows how the basic capability set extends into a more functionally complete developed capability set. ABS states that layered approach to cybersecurity enables organizations to select its implementation capabilities based on its needs. And the third set of capabilities, the integrated capability set, provides guidance for a fully formed and a highly capable cybersecurity system. So under the protect operational technology of the developed capability set that we just saw, some of the best practices and recommendations given is, so an organization integrates security requirements into operational technology, restricts and filters all traffic from control systems to operational systems, uses signed copies of software updates to its systems, and architects protective devices to limit traffic types and to trace and log all traffic into the network. The next guidelines we'll be looking at is by IET, the Institution of Engineering and Technology. IET is a multidisciplinary professional engineering institution, and they published a Code of Practice Cybersecurity for Ships in 2017 and was intended for use by those with responsibility for protecting the ships, cargo transport units, and those involved in the design and development of ships. So while this code of practice is concerned solely with the cybersecurity of ships, it recognizes that with a large population of security breaches caused by people and poor processes, it is essential that personal, processes, and physical aspects directly related to the technological maritime systems are also considered and appropriate measures are put in place. So this code of practice basically provides a management framework that can be used to reduce the risk of cyber incidents that could affect the safety or security of the ship, crew, or the cargo. So this document provides actionable good practice advice on areas such as developing a cybersecurity assessment and plan, devising the most appropriate mitigation measures, having the correct structures, roles, and responsibilities in place, and managing security breaches and incidents. So some of the good practices advised under devising mitigation measures for each of the aspects is that in terms of people, identifying high-risk positions, in terms of physical, enforcing physical security, and in terms of process, regularly reviewing access privileges. And in the technological side, measures like appropriate architecture, appropriate management, operation of critical security systems over a segregated infrastructure, and appropriate encryption technology to protect the data. So coming to the conclusion, we found few similarities between the guidelines that we just discussed. The first one is that the main groups of target audience focused on these guidelines are those at the management and decision-making level and at the operators level. And also one of the main focuses of the guidelines is on the cybersecurity assessment of ships, which is another similarity that we could spot. So through this study of existing guidelines on maritime cybersecurity published by various organizations, we saw the need to develop a set of guidelines that target those who are directly responsible for the day-to-day operations and security of shipboard OT systems, such as engineers and IT OT system specialists. So our new guidelines are aimed at providing specific technical and actionable mitigation measures for the major cyber risks that we have identified in the 4 shipboard OT systems, namely communication systems, propulsion, power control and machinery, navigation systems, and the cargo management system. So our guidelines will also take into consideration the balance of risk versus costs, and we'll also follow a tiered approach. So That's all from my side. Thanks for giving me this opportunity. I will now hand over the session to Ruchita, who will now present on the mitigation measures for cyber risk in shipboard systems. Thank you once again.
Thank you, Priyanka, for your slides. Good morning, everyone. Today, I'm going to present a study of mitigation measures for cyber risks in shipboard OT systems. The 4 OT systems we considered in this study are communication systems, propulsion machinery and power control systems, cargo management systems, and navigation systems. The first OT system is communication systems. In these communication systems, we have the subsystems: satellite communication system, integrated communication system, voice over internet protocol, wireless LAN. The cyber risks and mitigation measures of these subsystems will be discussed here. The first cyber risk is VSAT hardware can be vulnerable if software is not updated. The mitigation measures are: firewalls must be enabled on VSAT systems as the first line of defense against cyber threats. Virtual private networks must be used to access terminals with private internet protocol addresses. And also ensure the authenticity of vendor before downloading any fix or updates. Even ensure the latest software version is installed on terminals and updated regularly to fix security flaws. And all updates must be logged. The second cyber risk is usage of default credentials in the VSAT system allow access to the administration area. So the mitigation measures for this cyber risk are: change passwords regularly to minimize the likelihood of attackers gaining access to the VSAT modem. It is good to change password once in 3 months. Also make sure that the password is very strong so that no brute force or dictionary attack can solve it. Like for example, password with 12 characters and at least 1 uppercase letter and 1 special character is recommended. Another cyber risk is modems that only support insecure protocols are vulnerable to reflected cross-site scripting on web interface. The mitigation measures are: the web interface must be tested if it performs proper input sanitization. If any suspicious inputs are noticed, those must be rejected. Even also see whether output data is encoded. Also ensure that it uses content security policy. Continue here. Phishing emails attempt to deliver Trojan malware could include ransomware and cryptocurrency miners. So the mitigation measures for these phishing emails attack are: train the crew to identify malicious or phishing email, such that crew should not click on links from unknown sources or reveal personal or sensitive operation details in emails. Also install anti-malware program to prevent, detect and remove malware from the system. Secure multi-purpose internet mail extension can be implemented to encrypt the email and also ensure authenticity and integrity of email. The other cyber risk is weak protocols like HTTP can allow hacker to identify credentials or other sensitive information. So the mitigation measures are: the web interface must support secure protocols such as HTTPS and SSH v2 that use encryption for web traffic to prevent any attackers or hackers snooping on session. Other cyber risk is access to FTP can provide access to the entire operating system of the device. So the mitigation measures are: default username and password must be changed in the VSAT modem. Also block FTP access. Even check if the SATCOM terminal is available on the public internet. If available, then configure the firewall. So these are the cyber risks and mitigation measures of satellite communication system and integrated communication system. So in this slide, we will see the mitigation measures for the voice over internet protocol VOIP. The first cyber risk is a denial of service attack can flood the VOIP network server and slow down or stop any traffic. So the mitigation measures are: implement SIIP away firewall system that can filter packets from a malicious source. Second cyber risk is eavesdropping the traffic of an unencrypted network will lead to disclosure of confidential information. So encryption must be used on the VOIP network to mitigate this eavesdropping attack. Next one is vishing. Crew must be trained to identify vishing calls and must not give out any confidential information. The next subsystem is wireless local area network. Placing an access point where tampering can occur. So the mitigation measures are: access points must be kept in a secure location such as a locked closet. The next cyber risk is usage of weak encryption standards might lead to compromise of confidential data by eavesdropping attack. As a minimum level of security, wired equivalent privacy must be used. Stronger encryption standards like Wi-Fi Protected Access 2 or Wi-Fi Protected Access 3 is also recommended. The other cyber risk is denial of service attack. The mitigation measures are: security teams should constantly monitor networks for abnormal activity by using intrusion detection systems. And firewalls must be set up to reject any packets with spoofed addresses. Also, anti-malware programs must be installed in the system. The next OT system is propulsion machinery and power control systems. The subsystems under this OT system are engine governor system, fuel oil system, alarm monitoring and control system, power management system, emergency generator and batteries. The cyber risks and mitigation measures of propulsion machinery and power control systems are presented here. The first cyber risk is USB ports in the multifunction consoles raise the risk of crew inserting a USB drive infected with virus. The mitigation measures are: use port blockers to avoid unnecessary plugins. Also, antivirus must be installed in the systems. The next cyber risk is man-in-the-middle attack. Where tampering the internal serial communication between the OT systems, that means tampering the serial network like NMEA networks and CAN network, may lead to man-in-the-middle attack. So the mitigation measures are: physical security measures must be enforced strictly. That means only the crew listed in the access control list must be allowed to enter the engine control room or to any of the places where machineries are present. Even a secure serial to IP converter that supports encryption and authentication can be used. As serial to IP converters have web interface for configuration, default username and password must be changed. Even the converter device software must be updated. As the satellite communication is one of the entry point of entering into the serial network, the VSAT must be secured by ensuring the authenticity of vendor before downloading any fix or updates. Even securing VSAT is discussed in satellite communication system and integrated communication systems. Next is navigation systems. Under navigation systems, we have the subsystems: electronic chat display and information system, radio detection and ranging, automatic identification system AIS, Global Positioning System GPS, Dynamic Positioning System DPS, Global Maritime Distress Safety System GMDSS, Voyage Data Recorder VDR, and Integrated Navigation System INS. Let's see the cyber risks and mitigation systems of these subsystems. The first system is Electronic Chat Display and Information System ECDIS. The cyber risk is virus enters the system while a crew member injects a USB device into the USB port. So the mitigation measure is antivirus software must be installed in the ECDIS system to scan any external media connected to the system. The next cyber risk is an attacker obtains unauthorized access to the internet and overloads the network to perform the denial of service attack. So the mitigation measure is allowing only legitimate IP addresses or blocking ones from known attackers. These can be done by installing firewalls in the ECDIS system. So these firewalls will allow only known IP addresses. Spoofing attack can take place by spoofing incoming plain text messages to the ECDIS from the NMEA network. So the mitigation measures are encryption across the NMEA network ensures that data is encrypted before transit and authenticated upon receipt. So a secure serial to IP converter must be used which supports encryption and authentication. So these can be used to mitigate the spoofing attack. Next subsystem is radio detection and ranging radar. Hackers sends a virus-laden email via the ship's satellite link to the captain's computer. So the mitigation measure for this virus-laden email is the antivirus software must be installed on captain's computer which regularly connect to the ECDIS for chat updates. So this antivirus protects the system from virus-laden emails. Due to the vulnerabilities in server message block service, an attacker can perform the man-in-the-middle attack. The mitigation measure for this man-in-the-middle attack is by enforcing the signing to the underlying operating system of SMB service. MITIM attack can be mitigated. This SMB signing places a digital signature into each server message block, which is used by both SMB clients and SMB server to prevent the MITIM attack and guarantee that SMB communications are not altered. The next subsystem is Automatic Identification System, AIS. The cyber risk is attacker creates a fake terrestrial tower and transmit AIS data to the integrated AIS terminals by performing the spoofing attack. The mitigation measures are to distinguish between real and spoofed signals, we need a way to directly determine the location of the transmission. These can be done by using RFI application. Transmissions can be geolocated by time difference of arrival using this RFI application so that the location of transmission is determined so that we can compare the location of transmission with the location on AIS messages. If both are same, then we can say that was the authenticated message. If both are not same, then we can say the message is the spoofed one. The next cyber risk is an attacker delays the transmission time and retry it over and over, so he can perform the replay attack. The mitigation measure is monitoring the timestamps on all AIS messages, whereas Class A AIS transponders make use of SOT-DMA protocol, which is self-organized time division multiple access, whereas in this protocol, all AIS transmissions are based on GPS-derived UTC time. So, a crew member must monitor these timestamps on all AIS messages and can detect the message from the attacker and can detect this replay attack. The next cyber risk is an attacker could switch the target's frequency to another that is empty and can perform the frequency hopping attack. The mitigation measures are adopting a PKI schema in AIS protocol used in RF communication. X.509, a well-known PKI standard where digital certificates are issued by official national maritime authorities acting as certificates authorities 23 and concurrently configured in transponders with other station identifiers, whereas X.509 authenticates messages that station exchange. That means between ship and port authorities, even from ship to ship. Even these X.509 adopting PKI schema will mitigate the above mentioned replay attack and spoofing attack. So these can be used for all these three types of attack. The next subsystem is Global Positioning System, GPS. The first cyber risk is attacker attempts to trap a GPS receiver by transmitting a fake GPS signal and can perform the GPS spoofing attack. So the mitigation measures are: GPS receiver should detect spoofed signal from mix of authentic and spoofed signals by using detection techniques like absolute power monitoring, where in this technique, crew member must identify the power of the received signal. If that power is absolutely higher than the normal signal power, then it means that the signal was the spoofed signal. So in this way, crew member can identify the spoofed signal by using the absolute power monitoring technique. The other technique is spatial processing. In this spatial processing, what happens was when the attacker sends a signals, he sends the signals from a single antenna. Whereas normal signals will come, the normal signals are received from different satellites. So by using this spatial correlation of signals, the spoofed signals can be identified. The other cyber risk is jamming is usually due to the interference from signals on GNSS frequencies. So the mitigation measures are: spectrum monitoring enables GPS jammers to be detected and located by mobile direction finding systems so that unintentional jamming can then be warned and malicious attackers can be prosecuted. The other subsystem is DPS, Dynamic Positioning System. The cyber risk is an attacker can create a network storm on the GNSS receiver and can perform the denial of service attack. So the mitigation measure is installing the firewall in the DPS system will allow only known IP addresses. Even attacker transmit the false signals to the GNSS receiver and can perform the spoofing attack. The mitigation measure is to detect the spoofed signals by using the techniques mentioned in the Global Positioning System slide. So the same techniques can be used here to detect the spoofed signal, so that once spoofed signal is determined, that signal should not be used for making any positioning calculation. The other cyber risk is when an attacker gains an unauthorized access to the system, the attacker can perform the backdoor attack. So the mitigation measure is any advanced malware can detect and prevent malware and malicious attacks. Many backdoors are installed through malware, so it is essential to install an anti-malware tool which is capable of detecting such type of threats. The next subsystem is Global Maritime Distress Safety System, GMDSS. The cyber risk is the malicious firmware, if installed, could allow attacker to deliver false information by performing spoofing attack. So the mitigation measure is DKIM. DKIM adds a digital signature to every message. So these lets receiving servers verify that messages are not forged and were not changed during transit. Mitigation key generator tool helps in implementing DKIM in the GMDSS operating system. So this tool can help to prevent the spoofing attack in the GMDSS system. The next cyber risk is sensitive information is sent in plain text messages. So the attacker may intercept or manipulate these messages by performing the eavesdropping attack. The mitigation measures are: before sending the distress signal, encrypt the plain text messages so that the attackers cannot perform the eavesdropping attack while sending the sensitive information. The other cyber risk is group of networked systems are vulnerable to denial of service attack. So the mitigation measures are Use of firewall in the GMDSS system will prevent DOS attack by allowing only known IP addresses. The next subsystem is VDR, Voyage Data Recorder. Malware enters the system while a crew member injects a USB device into the USB port. So the mitigation measure is, before inserting any external media into the VDR system, scan the media for virus or malware using anti-malware software. The other cyber risk is vulnerabilities in services running on VDR allow attackers to execute remote code with the root privileges. So the mitigation measures are, most of the vessels uses older versions of VDR, like for example VR 3000 and VR 5000. So updated versions can help prevent these type of remote code execution attack. VR 7000 updated version is recommended. The next subsystem is Integrated Navigation System, INS. Remote Desktop Protocol Server running on the INS is vulnerable to man-in-the-middle attack due to the low encryption level used. So these MITIM attack can be prevented by operating system secure setup and by enforcing the strong cryptography. The next cyber risk is an attacker can gain unauthorized access to the system and execute remote code in the INS system. So the mitigation measure is update the operating system with a security patch released by the manufacturer to prevent these attacks. SNB 3.1.1 includes security enhancements such as enforcing secure connections with newer clients and stronger encryption protocols. So these are the cyber risks and mitigation measures of the navigation system. The next OT system is cargo management systems. The subsystems under this cargo management systems are cargo control room and ballast water system. The cyber risks and the mitigation measures of cargo control room and ballast water system are listed here. So the virus enters the onboard network via phishing emails with attached files. So any cargo control system connected to the network is logged out until a ransom is paid. So these may lead to a ransomware attack. The mitigation measure is antivirus software must be installed in cargo control computer system to protect the system from virus-laden emails. The malware injected into the bridge system caused the engine system to send the false command whether to increase or decrease the water in the ballast compartment. So the mitigation measure is, it is crucial that any external media is scanned for malware on a standalone system before being plugged into Shipboard network. So anti-malware software helps in scanning any external media for malware before being plugged into the system. So these are the cyber risks and mitigation measures of cargo control room and ballast water system. In this presentation, we have covered the cyber risks and mitigation measures of communication system, propulsion machinery and power control system, navigation system, cargo management system. The overall cyber risks of the four systems identified are USB ports, local area networks, software, GPS receiver, computer systems, very high frequency radio, network switch, server message block service, terminal, modems, and MEA network. And the identified measures of the four OT systems are antivirus or malware to detect the virus or malware in the system, and firewalls to allow only known IP addresses to mitigate the denial of service attack, and virtual private networks. Even crew training is important to identify the phishing emails. Encryption must be done to the plain text messages which are transmitting through NMEA network, and use port blockers to detect the infected USB drive. And also a serial to IP converter must be used to encrypt the NMEA network, and SMB signing is used in server message block service. Spectrum monitoring and absolute power monitoring is also used to detect the spoofed signals in GPS and DPS spoofing attacks. Thank you everyone Now I will hand over the session to the Mark.
Thanks, Ruchita. We'll now move on to the Q&A session, or you can also provide your feedback. So at the bottom of your screen, you can see the Q&A button, and you can use that to ask questions, view questions from other participants, or upvote questions that you see. By upvoting a question, it means that you would like this question to be answered. So the more upvotes a question gets, then the question will be bumped up to the top of the list. And then our panelists who are reviewing the list of questions would then answer those questions first. So I'll now hand over to Jianying as well as Priyanka and Ruchita to answer your questions. Thank you.
Okay, we saw a couple of questions being raised, and one is about the antivirus update. So how easy would it be to update antivirus signature, which is almost on daily basis, considering a bandwidth issue on each ship. So this question was raised by Panka, and I already shared the answer in the Q&A panel. And it depends on each vessel. They can define the updated policy, depending on what kind of the risks that a vessel may face, to decide the frequency of the update of antivirus. But in any case, as long as you can install this antivirus, well, it will significantly help to mitigate such kind of the attacks. Regarding the GPS spoofing question raised by Fei Xiang He, what's the maximum effective range, which means what is the maximum distance the attacker attack can be launched from the ship. And so here it depends on the attacker's capability. And for those vessels near the shore or is in a busy water area with many other vessels, they will be more subject to such attacks. And there are also other questions being raised. And one is how can GPS jammer be detected? Being raised by Remy Chu. Can Rachita answer this question?
Yes, Prof. So the upraised question is, how can GPS jammers be detected?
Yes.
Yeah, for these, spectrum monitoring can be used to detect these GPS jammers. Because these spectrum monitoring, analysis of frequency spectra can be done to determine the duration of interference and the signal type, so that we can determine the GPS jammers.
Okay.
And
thank you, Rachita. And we have another question from Fei Xiang. What is the common update methods for shipboard update? USB, over the air, or specially built tools?
I can answer, Prof.
Okay, yeah.
Yeah. So thanks for your question. And for ECDIS chart updates, it is usually through USB ports. And so they initially get a mail. So then they download it to the drive and then they insert it. But for updates, it is usually done over the air, as you said, from the vendors. Thank you.
Okay, Thank you, Priyanka. There are also other updates being sent through the satellite communication by email, and so we should also be careful to make sure that the update being sent by email be authenticated. Next question from Dana Pratomo. What can the product of a firewall to protect GMDSS? Actually, we would not recommend the specific product to be used, and we will only suggest the firewalls that can provide those necessary functionalities that to be deployed. So we will not recommend a specific brand of products to be used.
Prof, can I add some points for this question?
Yes.
And to protect the GMDSS, presently most of the vessels are using very high frequency radios. So usage of ultra high frequency radios, and there are some products available in the market which are already have the ultra high frequency radio along with the encryption methods. So usage of that type of radios can protect the GMDSS from vulnerable to the cyber attacks.
Thank you. And the next question is, does antivirus will not affect real-time performance of an ECDIS being raised by Lorenzo? We would expect those antivirus software be running in the background, and also not need to be making the real-time operation. So it will not affect the operation of the shipboard OT systems. Another question from Chu Hong Tam regarding antivirus. If there's a zero-day vulnerability, how will there be an effective measure when ship system needs to be in real-time operation? Actually, it's very hard to detect those zero-day vulnerabilities, and we don't have the effective kind of the solutions how we'll be able to detect the zero-day in real time, so this is one of the very strong attacks that the ship owners may need to be careful we at the moment we don't have a very effective method to detect in real time for such kind of the attacks.
Okay, so there's another question. If a vessel is not using VSAT, update is difficult. So most of the vessels, they use VSAT, and so that's how they do updates. And there are also manual updates where the vendor comes and does some services and all that, but it depends on you to secure your do the physical security measures. Thank you.
Another question from Seva Kumar. Due to the COVID-19, suggest a short video training on cyber security will suffice for onboard training. The rest will be more on the master's responsibility to ensure such a practice on cyber hygiene is constantly practiced. So this is kind of the comment being proposed.
Other question is from Ermer Magbanua. How can we update our navigational systems such as GPS, VDR, and AIS? So these systems can be updated by installing the latest OS versions and updated software versions. Like for example, for VDR, most of the vessels are using VR 3000 and VR 5000. So VR 7000 is the updated version. So installing these type of updated versions will help to mitigate the cyber attacks. Thank you.
Yeah, so how they update is, yeah, definitely it is through internet, through VSAT.
There's also a question from Dukovny. Is there any standard training for seafarers as they are vulnerable to cause cyber breach? Yes, definitely. The human is one of the weakest link in protecting the system, and as we mentioned in our recommendation, we need to provide the necessary training for the staff working on vessels, and this such kind of the training can be provided by in collaboration with the Maritime Authority and also the specialized organizations to provide such training to the seafarers. One more question from Pankia. With all the cyber security measures implemented, what will be the effect on performance of various systems? As this study investigate this issue? Yeah, this is one of the issues we need to study. And in the next step, we will evaluate the impact of each of those risks that may cause. And then we will give the priority, what kind of the risks need to be addressed first. And then also consider what are the potential impact on the performance of the overall OT systems operation. This one will be investigated in our next step.
Another question from Danang Pratomo. If engine control room not use computer with OS and not controlling with IoT from bridge and Shore HQ, is it possible hacker to capture the propulsion system? Actually, if this is the case, the most of the cyber attacks will be reduced, but there is another chance with the USB ports. Because USB ports will also may lead to the cyber attacks with the infected USB drive. Thank you. Other question is from Alden Pomperada. Regarding GNSS, only mentioned is software update. Will upgrading equipment such as antenna and receiver reduces chances of jamming or spoofing? For spoofing, we have mentioned the detection techniques like absolute power monitoring and spectrum monitoring. So these techniques will help to reduce the chances of spoofing attacks. And even for jamming, we have mentioned the mitigation measure of spectrum monitoring to detect the jammers. So for GNSS, or not only a software update, these techniques will help to reduce the chances of jamming and spoofing. Thank you.
Okay, there's one question from Ghazi. Will these slides be available for downloading? Yes, and we will make slides being available after this webinar. One more question, will there be a cyber security training video for shipboard personnel available, which comes with a certification? This one may need to work with the Maritime Authority and also the training organization to provide such kind of service. And iTrust will be happy to consider this in the later stage. There's one more question from Mohammed Lonok. It's difficult for non-IT personnel like seafarers to understand all the risks and mitigation measures. Are you planning any training course for seafarers? We as our first step, we'll try to make the guideline to be produced, being easy to understand and also easy to be enforced. And we'll also be happy to work with the Maritime Authority to provide the necessary training in the after that. Yeah, thank you.
So there's a question from Janilan Ravako. Could you recommend a USB vaccine? That this USB vaccine can help to protect electronic onboard against hacking attack. So there's no known reports that they have been using USB vaccines, but Panda Labs USB vaccine is one of the well-known USB vaccine, and it acts as a protection to system and helps in disabling automatic execution of malicious files. Yeah, thank you.
I think we can take 2 more questions before we move to the closing remarks.
There's one comment from Yuki Men. Many antivirus softwares are available in the market. However, too few softwares are capable of detecting ransomware that are newly created. Further, if a vessel is not using satellite VSAT, then there's no it's not complete. The purchase not complete. Yes. So we need to look for the antivirus softwares that be able to also provide the capability to detect the ransomware. If those ransomwares also are new, not within the signature database of the antivirus software, it will not be detected. And we always face such kind of risk, even if antivirus software is installed. Okay, let me try to answer the last question. There's one question from Shasha Khan. We have a lot of incidents of GPS spoofing. Did we come to identify any hacker? This one, it's up to we need to provide all this information being recorded in the log. So after the kind of the attacks, such as spoofing attacks being recorded, then the forensics can be carried out to identify the potential attackers, but it may not be always possible to identify who is the actual hacker. Okay, I think there are still many questions not be answered yet. We try to answer those questions offline and provide it to the be available on our website. So yeah, so we will come to the end of this webinar. We would like to thank everyone for attending our webinar, and also thank you for your valuable comments and feedback. And we will schedule a third webinar in August to share our draft guideline for further comments. And once again, thank you for your support to our efforts on maritime cybersecurity. Thank you.
Thank you, Jining. So thanks again for joining us in this webinar. We hope you gain some useful insights. So as what Prof mentioned, we will send an email after the webinar to let you know where to download a copy of the slides, a copy of this recording, and we will also collate all the questions that have been asked and give you the corresponding answers in a Word document. And all these can be downloaded as a package. So do check out our website, look out for our email, and also the announcement on our LinkedIn page. So as Prof mentioned also, the next webinar will be in August. That will be the final webinar for this research study. So we will wrap up the study and also provide the guidelines as well as the checklist for maritime authorities as well as vessel owners to use to conduct their own inspection on the cyber hygiene of their ships. So that will be a very interesting webinar to look forward to. So have a good long weekend in front of you, and thank you for joining. See you next week at the next webinar. Thank you.
Thank you.
Thanks, everyone.
Thank you, everyone. Bye.